Hello, my fabulous chemistry minions. Video number 10. Today, we will take on the most important elements and be able to recognize them by their name and their symbol. Good? And let's get right to it. So, basically, the most common elements that we use on the periodic table are within the first 30 elements. Some of the ones that get farther down are ones, honestly, I've never seen before, don't have very much experience with. The first 30 are the most prominent ones, and then there's a few other metals that we'll find that are outside of the 30 that are very, very common, like iron. Okay. And I'm going to give you some symbols with their names. I'll write down at least what's in blue, that Li equals lithium, but I'm showing you that it's lithium and it's element number 3, you'll see in the bold there. So there's lithium. That one kind of makes sense by looking at it. The rest of these might be problem elements for you in the future. Fe in Latin is ferrous, which means iron. It takes the Latin root. Okay, so iron is Fe. Na is sodium. You've heard of sodium chloride. Most of you put it on your French fries, or it already comes on your potato chips. K is potassium. Those we eat bananas for. Copper is Cu, element number 29. Element 79, Au is gold. And Pb is lead. I just wanted to put some of those out there because they're kind of problem elements, as in their symbol doesn't match their name perfect. So it's good to know those ones and kind of commit those to memory. There are also 7 special diatomic elements. Diatomic means 2. Okay, they're always paired. That's where I get the di from, atomic, atoms. And there are 7 of these guys. So we got to remember all 7. Okay, and we will quiz you on these later, I promise. So H, hydrogen. O, oxygen. F, fluorine. Notice it's spelled funny. It takes me a long time to. I always want to do O-U-R, like flower. Br is bromine. Luckily, most of these, their symbols and their names match up. So here's where we get into some problems. This is iodine, and this is the capital I. So the font that New York State uses on the reference table, that is a capital I. Keep that in mind. I'm going to show you in 2 elements how that gets confusing. N, nitrogen, very common element in bulk of our air. And here's where the real problem comes in. This element is Cl, chlorine. It's not capital C, capital I. And a lot of kids want to do that because that little lowercase l is the exact same character as the capital I. That's where the biggest problem comes in on the reference table as far as the periodic table and New York State. So we need to know that capital C, little l is chlorine. There's probably the only one that really gets a problem with reading the actual font of the element. Okay. This is how we remember it. These 7 are Hofbrinkel, and now you can see in there, if you can remember Hofbrinkel, you can say hydrogen, oxygen, fluorine, bromine, iodine, nickel. I'm sorry, not nickel, nitrogen, and chlorine. Okay, good? Deep breath. Moving on. Okay, there are 2 liquids on the entire periodic table. Hg is mercury. He's the only liquid metal. And there's one other one. Bromine is the liquid nonmetal. Those are the only 2 that are liquids. There's a handful of gases, and the rest are solids. Hydrogen is a gas. Helium is a gas. We know this. You've heard of helium balloons. Nitrogen is a gas, the element that's most abundant in our actual atmosphere. Oxygen is a gas. We're breathing that. Got it. With some nitrogen, of course. Fluorine is a gas, the most reactive non-metal, by the way. Neon is a gas. We've all seen neon signs. It has a specific color when I hit it with electricity. Chlorine, we just did this, but it's important to do it again. Chlorine, Cl, is chlorine. It is also a gas that's very poisonous. Argon, another noble gas. Argon will make a different color in those neon tubes and make the signs a different color. Some of them are argon. Krypton, Kr, is a gas, part of the noble gases. And xenon, another gas. And I believe any of those could be in the lights, like the neon lights that you guys see. Radon, Rn, another poisonous gas, and a member of the noble gas family. And, oh, we're almost done. So now I'm just going to try to show you where on the periodic table to find metallic and non-metallic elements, okay? So you might need to watch this. This is the part you're right. The elements above and to the right of the staircase, not touching the staircase. So these are the non-metals. And I'm going to show you in a picture what I'm talking about. So let's take a better look at this periodic table. It says to the right and above the staircase. Well, this is the staircase. You see it in bold? We call that the staircase. And that's going to separate metals from non-metals. And above and to the right. So above and to the right, notice the elements that I'm shading in are not touching the actual staircase. They're not on it. Okay? Those are special elements, the ones that are right next to it. So those are all of the non-metals. The bulk of this chart is, of course, metals. Okay? Metalloids are the elements that are touching that staircase, all of them except for Al. Al is aluminum, and we all know aluminum is a metal. We've held aluminum cans in our hand. Can of tuna, can of Coke, aluminum. Can of soup. So again, the staircase is here. Okay, and now touching the staircase, and notice I didn't highlight Al. So all of those in yellow are what's called the metalloids. Metalloids or semi-metals have some character of metal and some character of non-metal. They're not perfectly metal or non-metal. They're kind of they're kind of where they transition from metal to non-metal. I don't want to confuse you. There's a whole other section called transition elements. So they're the mixtures. Okay, they're on the staircase. Metallic elements are everything else. So all elements below and to the left of the staircase, of course, not touching, because if I'm touching, I'm generally a metalloid. So again, the staircase, bolded line, looks like a set of stairs. Everybody to the left, which is at least my left, which I mean is probably this way to you, right, these are the metals. Notice I highlighted aluminum this time, but then I'll miss all the transition metals. Now I'm not going to highlight the UUT. These have been named since New York State has had these reference tables printed in 2011. They were just named a year or two ago, but these are man-made elements, and they're really not in the scope of this course because they don't exist very long. They're very, very reactive, and they do not hang out for but nanoseconds at a time before they decay into some other element. And we literally have to create them by bombarding and pushing together atoms. So we're not going to really deal with those too much. Metals to the left, which is for you this way, right? Ooh, sorry. There's the metals. So I think there's our metals. Study up. I do want to show you that on your periodic table. There is the periodic table that we just did. For doing the next piece, where you have to list them, here is a list of the atomic numbers and their names. So the atomic number for hydrogen is 1, and if we don't know that that's the atomic number, there's a key up here that says the atomic number for carbon is 6. Atomic number for carbon is 6. When I flip to the next page, if I go down to 6, it's carbon. So I want you to get used to the first 30 elements plus a few choice ones on the you-do following this video. I think you can do it without me. See you tomorrow in class.